All right, anybody need help finding this? We're all good, looks like, we found it. Okay. So I'm gonna dive right in just a moment, but before we do that, somebody asked, what is trigonometry? So let me try and sum up a massive concept in a few very short words, but I'm gonna write on here, I'll erase this, but just to give a little picture, you guys may remember something like this. Whoops, that's not what I wanted. A squared plus B squared equals C squared, right? You guys know that? Okay, so Pythagoras developed the Pythagorean theorem, right? Which dealt with right triangles, and it had a relation. It just kind of observed that if the side in a right triangle were to change size, that would then affect the hypotenuse for the other side. So for example, let's say that A gets longer, then okay, that's going to affect the hypotenuse of that triangle. And so they did all these calculations and found out if you do the two legs squared, add them together, then it would be the hypotenuse squared. So they came up with this theorem looking at these distances or the relation between the sides of a triangle. Trig is kind of a spin-off of that because it not only relates the sides of a triangle, but also relates an angle as well, or any angle within the triangle. So for example, if I were to extend that side, not only does the hypotenuse change, but this angle has now also changed. And so is there a relationship between the change in the angle and the length of the side? And it happens there is, and they came up with all these different ratios. So trigonometry, we're just going to be relating not just the sides together, but the angles in the sides together. We're going to start off doing that specifically in right triangles. Okay. So I'm going to throw some words out there and write down definitions, and then hopefully they will make more and more sense as we use them quite a bit. But there are three basic trig functions, and they are listed here, okay, as trig ratios. And they are pronounced the sine, the cosine, and the tangent. But when we write them, we usually just use an abbreviation because we are mathematicians, which means we are therefore lazy, or let's say efficient. And so when we write them as an abbreviation, we just write SIN, COS, or TAN. All right, but you guys, being mathematicians, when you go to your calculus classes, please do not call that the sin, because then your calc teacher will yell at me, and then I will yell at you. It's the sine, okay? So SIN, that's the sine. This is the cosine. This is the tangent. And we're just abbreviating that with 3 letters. It also fits on your calculator nicely with just 3 letters. And so what are those ratios? They are ratios of sides. The sine is the opposite divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse. And the tangent is the opposite over the adjacent. So we will work with those so much that, you'll learn them pretty quickly. So the sine is and we're talking about side lengths, okay? Sine is the ratio of the opposite side over the hypotenuse. The cosine is the adjacent over hypotenuse, and tangent is opposite over adjacent. Now, these are the 3 most famous trig ratios, but there are 3 others that we're going to talk about. And I'm going to write them in kind of a weird order. So I'm going to write cotangent. I'm sorry, I should have scratched that off there. Where it says, what did it say there? Definition, okay? We're not going to worry about that right now. I'm just going to write cotangent, secant, and cosecant. Okay, those are the other three functions that we're three trig functions that we're going to deal with. And they also have abbreviations. So for an abbreviation for the cosecant, that is CSC. And for the secant, that is SEC. And for the cotangent, that's COT. Now, the reason I wrote them in the specific order is because looking across, they go together, meaning the sign matches with the cosecant in the sense that the ratio of the cosecant is the sign flipped over. So the cosecant, since the sign is opposite over hypotenuse, the cosecant is the hypotenuse over the opposite. And similarly, the secant is the cosine flipped over. So the secant is the hypotenuse over the adjacent. And the cotangent, of course, is the tangent flipped over. So that's the adjacent over the opposite. So those three on the right, just because they are the original ones flipped over, they're called reciprocal functions, okay, because we just flip over the original. And so they, they are the sine, the cosine, the tangent, the cotangent, the secant, the cosecant. So again, in order: sine, cosine, tangent, cotangent, secant, cosecant. And it's helpful to remember that which ones pair with each other. One way to remember that is that every pair has a co in it, like sine goes with the cosecant, as opposed to the cosine going with the secant. Students screw those up all the time, like, all right, does sine go with secant or cosecant? I can't remember. It has to have one co in that pair. And tangent and cotangent are not confused as often. Those fairly obviously go together. All right, so what does all that stuff mean? Let's start to give it a little bit of a picture down here, okay? So we have this right triangle down here, ABC. And we want to fill in the information. Well, the hypotenuse, that of course is the side across from the 90-degree angle or opposite the 90-degree angle, which is segment AB. And the hypotenuse is usually kind of the easiest of the three sides to find, as opposed to the opposite or adjacent. Not that the others are too bad, but we're going to write down the opposite of A and the opposite of B, and so on. So if we look at angle A, so here's angle A, and I'm looking inside the corner here. If I want to know what side is opposite that, well, think if you were to lay your pencil down inside angle A, it would be pointing at BC. That is the opposite of A. So segment BC is the opposite of A. I'm going to go down, I should have said. The adjacent of A, adjacent means next to. If I look at angle A, though, I really have two sides that are adjacent to it. I have this one here and this one here. But remember that AB is our hypotenuse, so that means that AC must be the adjacent side. So just trying to give you an idea of how to come up with the opposite, the adjacent, and the hypotenuse so that we can make the trig functions from them. All right, so let's focus now on angle B. So this angle right here. So if that is our focus, we know that AB is our hypotenuse. The opposite of AB would be there, would be AC. And since this is our hypotenuse, then the adjacent would be BC. So the side opposite angle A is AC. And the side adjacent is BC. All right, any questions yet? Good? All right. Well, let's take a look at number 2. We want to determine which of the trig ratios make the equation true. So here we're looking at angle L. And if this is our focus, our ratio is 24 over 25. And so I look at angle L, and in relation to angle L, the 24 is the adjacent, because that would be opposite. So the 24 is the adjacent, the 25 is the hypotenuse. So then I have to think, if this is the adjacent over the hypotenuse, which of our trig functions is adjacent over hypotenuse? That is the cosine. So my answer for that the cosine of angle L is 24 over 25. So working down here for M, if our focus is angle M, 24 is opposite, 7 is adjacent. And so opposite over adjacent is the tangent. So we would say that the tangent of M is 24 over 7. So take a second and fill in what you think, what function you think goes here for angle M if we end up with 24 over 25. All right, so if M is the angle we're focused on, we look at 24 as opposite, 25 is the hypotenuse, and the function that is the opposite over the hypotenuse is the sine. So we would say the sine of angle M is 24 over 25. All right, number 3 here. This, by the way, this little symbol right here, anybody know what that is? No? No Greeks? It is theta. It's a Greek letter, theta. It's not a 0, okay? It's just a variable. It's used a lot in math, especially in trigonometry. I'm not quite sure why it's so famous, but it's used quite often in referring to angles, angle theta, okay? So this is saying that the cosine of theta is 4/5. Now my picture didn't work out very well. So that angle up there at the top of the triangle, if you could draw in there, is our angle theta. The cosine is the adjacent over hypotenuse. So I want to label on my triangle, the adjacent is 4, and the hypotenuse is 5. Okay, so I use this information to label the triangle. The cosine of angle theta is adjacent over hypotenuse, or 4 over 5. So what's the base? Come on, that's supposed to be an easy one, Pythagorean triple, people. It is 3. That's a 3, 4, 5 triangle, okay? Or we could do, 5 squared minus 4 squared and take the square root, do old Pythagorean theorem stuff. But now that we have that third side, we now can find these trig ratios. We can find the sine of theta. The sine of theta is the opposite, which is 3, over the hypotenuse. The cosine, I'm going to write the cosine under here. The cosine of theta is the adjacent over hypotenuse, which is 4/5. The tangent of theta. So again, here's the angle. Tangent is opposite over adjacent, so it's 3/4. All right, any questions on how we found the sine, cosine, and tangent on that? Because if we can find the sine, the cosine, tangent, we should be able to find cotangent, secant, and cosecant. And I'm not even going to look up at the definitions because remember the relation that the cotangent is just a tangent flipped over. So it will be 4/3. So the cotangent of theta is 4/3. The secant will be the cosine flipped over, which will be 5/4. And the cosecant will be 5/3 because it is the sine flipped over. So we're just trying to get used to, what are the relations between the angles and the sides, and then how are those trig ratios related to each other out of the 6 of them. Okay, any questions before I have you guys try some?